Hello again. Thanks for joining us on Space Nuts. Andrew Dunkley here, and it's a Q&A edition. That means that we're going to answer questions, or we're going to pretend to, or we're going to refer them to a future episode for possible answering or not. Or maybe we'll just put them in a bin. I don't know. What do we got today? We're looking at life and death within the universe, not the life or death of people, or other entities for that matter, but maybe the life and death of planets and galaxies and maybe the universe itself. What's that all about? We'll tell you. We're also going to look at how black holes grow. That question's been asked. Another question about space junk and seeing the Milky Way in the UK. How do you do it? You get a very tall ladder to get above all the smog and the clouds. That's what I reckon. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And it's good to have Professor Fred Watson here to answer all of those because I haven't got a clue. Hello, Fred.
Oh, yeah, true. Neither have I, really.
Well, we'll do our best.
We'll muddle through, don't
yes.
worry.
We have a homework segment that we occasionally do when a question gets too hard.
That's right.
Might take us 3 or 4 months to get back to you, but we do it. We do it. What's the rush? Shall we begin?
Well, why not?
Okay. This first question comes from Trevor. Trevor's in Port Macquarie, which is up on the mid-north coast of New South Wales, Australia. Horrible part of the world. Nobody wants to live there. I mean, they've got beautiful green trees and subtropical forests and white beaches and fishing. And why would you want to live there? Okay, Trevor. Nice to get your question. Hi, Andrew and Fred. Everything in the universe is born at some point and has a lifespan. On Earth, at the end of their life, at the end of their life, plants and animals return to the soil from where they came. In space, suns and planets live and die and eventually become part of the space around them once more. So could this be true for the entire universe? We think we know that the universe was born in the Big Bang and that it will probably die at some point in the future. So I'm wondering if, over the eons of time, could the black holes that seem to be at the middle of every galaxy eventually pull everything currently in the universe back into one singularity, at which point we would have another Big Bang and a new universe would be born. Many thanks for your program. I listen in bed every night and it helps me go off to sleep at least twice a week. I'm glad we can do that for you, Trevor. We put him to sleep, Fred.
That's right. And that's something I'm really good at.
Boy. I'm sure he didn't mean it that way.
I'm sure he didn't know. Look, Trevor, great to talk to you. You have, as you might know, in Port Macquarie, a brand new, marvellous science centre in the middle of town, which is being opened a little bit later in the year. It's on the site of the old observatory there, which I was always very fond of, and indeed was its patron. And I think I might be the patron of the new science centre as well.
Oh, wonderful.
Which is brilliant. And so that opens in a couple of months. So make sure you go along and check it out, Trevor, because you're in pole position to do that up there in Port Macquarie. And the answer is, well, yes, it's true. Everything seems to have a life cycle. And the theory that you've mentioned, that the gravitational pull of everything in the galaxy, in the universe, might eventually cause the universe to collapse back on itself into another singularity.
The Galactic.
The Galactic, that's right. The opposite of the Big Bang. That's the name coined by Brian Schmidt before he did his Nobel Prize-winning work. We usually called it the Big Crunch. The idea was that everything would eventually collapse back on itself and would be a big crunch, which may have spawned another Big Bang. And that would be a new universe being reborn, exactly as you've said, Trevor. What basically threw cold water onto that argument was Brian himself and other colleagues in the United States who together in 1998 discovered that actually the universe, its expansion is not slowing down as you would have had to have if you're going to get a Gib or a big crunch. It's accelerating. So the accelerated expansion of the universe really knocks that on the head. And it also tells us that there is something in the universe that is causing space to accelerate, not just expand, but to expand ever more rapidly. And we call that dark energy. And if you thought dark matter was a mystery, wait till you get to dark energy. We really have very little idea of what it is. It's some sort of vacuum energy. It's some kind of energy of space itself. The more space you get, the more energy you get. And it's causing the universe to expand ever more rapidly. So it looks as though the universe may never have an ending if it just keeps on going and expanding. Unless the thing that some other people have hypothesized, that one day space itself might just get so stretched by the accelerating expansion that it fractures and you get something called the Big Rip. And the Big Rip is another possible end to the universe when space itself just gets ripped apart.
Well, yeah, that seems to be the popular opinion at the moment, doesn't it?
It is, yeah. The Big Rip is a little bit hypothesized, but certainly the accelerated expansion is taken as fact now since that discovery was made. It's not just the observations of supernovae, exploding stars, that were what allowed that discovery to be made, but many other observations of the state of the universe, if I can put it that way, imply that the dark energy is there.
Okay, there you are. So in regard to his question about life cycles in the universe, we are seeing that, and eventually everything's going to finish in terms of the physical forms, the stars, the galaxies,
that's right.
The black holes themselves may well, in billions upon billions of years, evaporate because they are burning their energy. They're getting weaker over time. It's just a very slow process. But the universe as a whole, that's a different question, I suppose.
Yes, that's right. So you're right in that the kind of life and death processes that involve stars, and stars are the main kind of matter in the universe, apart from dark matter. They're the way we detect matter in the universe anyway. That life and death cycle is well known, and when you look forward perhaps 100 billion years or so, all you've got is dark remnants, black dwarfs, we call them, remnants of stars, and probably a lot of black holes as well. So everything's kind of dead and dormant. There's no black holes are not feeding because there's nothing for them to feed on. So it becomes a very boring universe indeed. And maybe a Big Rip would be the fitting end for a universe like that.
And once everything's expanded beyond our capacity to see them, no astronomers, Fred.
Damn.
Yeah. You'll have to retire then.
Look, I'm just a dying breed. Oh, that's terrible. I never thought of that.
How many gazillion years away is that? Yes. Anyway.
Quite a few.
We're in no rush. Thank you, Trevor. Hope you're enjoying Port Macquarie. Lovely, lovely place it is. Let's go to our next question. This one comes from David.
Hey, Fred and Andrew. This is David from Seguin, Texas. Just sitting here in bed thinking about black holes and questioning how is it that black holes grow? Like when a black hole over time becomes a supermassive black hole, how is it that they grow? Because if their gravity can suck in even light and they're supposed to be infinitely dense, why don't they just stay the same size and just continue eating? Why do they grow as they eat? Like, what is it that's growing? Thank you guys. Love the podcast.
Thank you, David. Yeah, it's a tough nut to crack, isn't it? The old black hole. What's it eating? How's it getting bigger? They eat each other, or they merge. We know that. But yeah, it's a good question. Why don't they just stay the same size? Why do they keep growing? What is causing that? What are they actually eating?
Well, yes, I think the issue is not so much what they're eating, because we do know they gobble up anything that's
basically anything that can catch.
Yes, that's right. Not that they go chasing around the universe to find them.
No, they're more like a trapdoor spider, aren't they? It's
yes, or indeed a huntsman spider, which also just grabs things. But so that all goes into the black hole. All that debris, stars, gas, dust, other black holes occasionally, all goes into the black hole, apart from what's shot out, by the way, by the magnetic fields that give you the jets from an active black hole. But the question's really about why doesn't it grow? Now, it doesn't grow in physical dimensions because, by definition, a black hole has 0 dimensions. It's a singularity. And so its volume is 0. And we know, I think the way we define a black hole is a point in space of infinite density. So its density is infinite. Now, density is mass over volume. Density is infinite because volume is 0, and you're dividing something by 0, which produces infinity. That's the density. But that says nothing at all about its mass. And the mass is what changes. So it's not the size of the black hole, but it's mass that changes. Okay. They do grow, but they grow in mass. And that's how we get the supermassive black holes, because they've been at it for a long time and accreting this material. So, they do grow. They don't get physically bigger. Their mass gets bigger. And in turn, the event horizon gets bigger. So that's the bit that delineates where you can't penetrate. Nothing can penetrate out of it, not even light, is the event horizon. And so as a black hole gets bigger, its event horizon grows and grows and grows. Even though it's still a singularity, but its mass is going up, and that causes the event horizon to swell.
Okay.
Yeah.
And so you can do this experiment at home by eating 100 donuts. It's exactly the same thing. Your mass increases.
It does, but usually your volume does as well if you do that. Yes, I won't do that any further.
Okay, fair enough. So what was the answer to the question? The mass increases, but the black hole doesn't.
The dimensions don't. The dimensions of the event horizon do, because they're linked to the mass. So it's the mass that increases.
Okay. There you go, David. You can go to sleep now. Sitting in bed trying to figure out black holes, that's self-inflicted torture, that is. But yes, at least somebody's trying to figure it out. A lot of people are trying to figure it out, David. Thanks for the question. Lovely to hear from you, and I hope all is well in Texas. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, we've got another audio question, this one a little closer to home, from Mikey.
Hey, Fred. Hey, Andrew. This is Mikey from Illinois again. I was wondering about space junk. There's a lot of it around Earth right now, and there's only going to be more, come the future. And if nothing ever gets done of it, I was wondering if somewhere in maybe the distant future, all of this space junk would kind of coalesce, and the Earth would maybe have its own artificial ring system, kind of like Saturn, but just instead of ice, rock, and dust, it's junk. Just something that kind of crossed my mind. Wonder what you guys think about it. Thanks, guys.
Yeah, that's a really interesting thought. And it's out there. Some of it re-enters, some of it burns up. Some of it's just floating around out there, and it can be as small as a fleck of paint. But it's moving at a rapid speed, and it has had a few close calls and caused a few problems from time to time. In terms of dealing with it, it's every nation's responsibility to look after their own stuff, isn't it? Or every entity's responsibility. Yes. Although that's only a recent law, and we're still, grappling with it. We've been experimenting with ways to collect the stuff, but I think there's just too much stuff.
Well, it's not that there's too much. It's that it's kind of spread all over the place.
Yeah.
And space is big, as Douglas Adams put it. But, just thinking about this, Mikey's point, and in a way, the Earth already has a ring of debris because it's the geostationary satellite ring. That's where there are very large numbers of satellites. I don't know the total number that's in geostationary orbit, but it's quite large. And beyond that, there is what they call the graveyard orbit, where geostationary satellites have to be pushed out into a graveyard orbit once their useful life is over. And it's a fairly stable orbit, one that's not, being perturbed so that a satellite will collide with another satellite. So we've already got a ring, the geostationary satellite ring. Most of them are in one piece because we use them every day for communications. But in terms of the low Earth orbit and mid-Earth orbit spacecraft, yes, there is a lot of debris around because these spacecraft collide with one another from time to time. It's, as you said, flecks of paint, everything upwards from flecks of paint. And it just begs the question whether at some time in the future they would actually coalesce into a ring, the orbits of these things would flatten out so that rather than having orbits at all inclinations, they're going all around the Earth, so the Earth is like inside a shell of space debris, whether it would flatten out into a ring. And I suspect it would in the very long term, that you would end up with a ring of space junk. However, we're a long way from that. I think the thing about the low Earth orbit stuff is that will burn up before we ever get to that stage. So they'll re-enter and burn up and cause pollution in the upper atmosphere, which we now know is happening, detecting aluminium and other stuff like that in the upper atmosphere that comes from re-entering spacecraft. But that's a vapor rather than a solid entity like a ring. So I think the answer to your question, Mikey, is we've got a ring already, and most of it's useful, but some of it's not.
No, and long term, maybe some of the stuff that is orbiting by default and won't return to Earth may well become a ring.
Yes, that's right.
Assuming we don't find a good way to clean it up in the meantime.
Yeah, I mean, we could, there's many projects that have been launched and some have actually been launched into space, but they're ways that you can either throw a grappling iron or a net or something at a piece of space debris and slow it down so it does re-enter the atmosphere. That's becoming, or maybe it's too early to say it's becoming, but it will become a standard procedure, I think, especially for large pieces of debris that if they re-entered in an uncontrolled fashion, they could do damage. I think that's going to be the norm. It's also the norm, as you hinted at, that any nation that launches anything into space, or any organization that launches anything into space, has to demonstrate that they've built in a way of deorbiting it. Yeah. In other words, they can get rid of it. And that, I think, has been in place for quite a few years now. So in the long term, we're in better shape than we are at the moment. Hopefully, the space junk situation will improve.
Indeed. All right. Great question, Mikey. Thank you very much. One more question, possibly two. I don't know how we'll go for time, but we've got a question without notice from YouTube, I assume, or something to that effect. But this one coming from Ian, who is in Cambridge. Hi, Andrew and Fred. I asked a question last year about not being able to see the Milky Way. I still haven't seen the Milky Way here in the UK. However, there are some photos on social media showing the Milky Way high in the sky above Stonehenge. Are these genuine? I would have thought from the UK perspective, the Milky Way would be low in the southern sky. Thanks for the great podcast, Ian. Well, you're from the UK, Fred, so you know the lie of the land and
the lie of the stars.
The lie of the stars in perspective to the positioning of the northern hemisphere. Can you see the Milky Way from the UK even on a clear night?
You can. And the Milky Way, it goes all the way around the sky. So everywhere on Earth we'll see it at some point. The best time to look from well, there's two kind of good times, I suppose, from the Northern Hemisphere. Is the middle of winter, because the Milky Way stretches right up, goes past Orion, goes through Cassiopeia, all those constellations. It goes right, basically from north to south across the sky. It's in the middle of the year as well. You can see it quite well. I think what Ian is really meaning, though, is the center of our Milky Way galaxy, which is the brightest part of the Milky Way, which goes directly overhead here in Australia, but it only skirts the southern horizon in the northern hemisphere, certainly at the latitude of the UK. So you can see it. I've observed Sagittarius, which is where the galactic center is. I've observed it from Scotland, actually, but it's been very, very low down in the sky and very difficult to see because there's pollution and light pollution and everything there. But the Milky Way itself goes all the way around the sky and is visible, as I said, best in midwinter. In fact, in the middle of summer, there's too much daylight. The nights last too long, or the days last too long. But the main thing is to be away from light pollution, and that's because the Milky Way, as seen from the northern hemisphere, is fainter than it is in the south because we've got the galactic center where it is richest. Milky Way is at its brightest. So you are right in that the Milky Way is fainter in the northern hemisphere, but it's still visible. And on a dark night away from city lights is pretty impressive. So that picture of the Milky Way over Stonehenge would not necessarily be a fake.
Okay, I've looked at a few here, and one of them's referring to a photograph on a summer night at Stonehenge, and it's showing the Milky Way vertical. How does that sound to you?
Yeah, that would be right. It would be vertical.
Okay.
Yeah. As it is in winter as well, on a midwinter night.
Okay. There you have it, Ian. So it's probably genuine. There'd be a lot of others out there that have been constructed from superimposed photographs, but yes, it is a possibility. Thanks for the question. One quick one without notice, Fred, comes from, I think TTJ has messaged us before. He's just got home from work. Do have a question. Does the early spring affect viewing of the skies in any way?
Only weather-wise. We've got probably warmer weather that should produce drier atmospheres and give you a better view. I noticed I've got a bit of a weather station on the wall. I noticed the pressure's low actually at the moment. It's much warmer than it should be in winter.
Yeah.
The air though is very dry compared with what it normally is like, and that normally gives you better viewing, less twinkling in the sky because the amount of turbulence in the atmosphere settles down when the air is drier.
How about that? There you go, TTJ. Thanks for the question at the last minute, and he's in Sydney as well, Fred. Probably across the road from you.
Could be indeed.
Yeah. Wrestling goannas. Yeah.
Yes, that's right.
And a reminder to anybody who wants to send in a question to us to go to our website, because that's where you send them, and you can do text questions. Just click on the AMA tab or link at the top. You can also send audio questions that way, or on the right-hand side where you would usually be, send us your voice message, and it's not there today. Don't know what happened to that. Probably my computer doing silly bugger things like it tends to. But yes, we welcome your questions for our Q&A episodes of Space Nuts. Keep them coming. Thanks, Fred, as always. It's a great pleasure.
Great to talk to you, Andrew. We struggled through and we got some good answers there, I think.
Yeah, I think so. And we made them all up as we went along. We didn't even have to sit down before the show and work out fake answers. We made them up as we went along. It was brilliant. We're getting better at this. Thanks, Fred. We'll see you soon. Fred Watson, astronomer at large. Thanks to Hugh in the studio who sent us one question. Yeah, we can't tell you anything about that at all, Fred. Hugh, we don't know the answer. Talk to your electricity provider. And from me, From me, Andrew Dunkley, thanks for your company. We'll see you again soon on another episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.